All right, hi there, ladies and gentlemen. Today we're going to be looking at rational exponents and radicals. So the first graphic I'm going to show you, I'm actually going to ask you to pause the video and write it down, because you're going to hear me use these vocabulary words like radicand, radical sign, and index. So here we're going to write each expression with a rational exponent. So the way this works is you have a radical and a radicand. So typically when you have a radical, the radicand is a 2, but we don't have to write the 2. It's implied to be a 2. So let's say you have a radicand, or an index of 4, and you have x to the third power under there. So you have an exponent, you have a radical, and you have an index. And of course, the radicand is under the radical there. So I can write this in exponential form. So I can pull this out, the x, and what's going to happen is it's going to become a rational exponent. Remember, rational means fraction usually. So I'm going to create a fraction with the 3 and the 4. The 3 becomes a numerator of the fraction, which is the exponent, and the index becomes the denominator. So in this case, you would have a variable, you would have an exponent, and then you would have the index just under that. So for example here, I have an index of 3. So this would be 125 to the 1/3. Because there is no exponent, the exponent is a 1. Same thing with the other one. This would be 16 to the 1/4. Now, we can solve this. Basically, what this is asking is what number times itself 4 times will give you 16. And I believe in this case it would be 2. And here this would be 5. So here we have one that's in an expression that is in exponential form with a rational exponent. So the 12 right now that's hanging out front doesn't mean anything. That's 12 times something. So I'm going to put the a here. I'm going to create a radical. Remember, the number up top is the index. I keep saying that wrong. I'm so sorry. That is not the index. That is the exponent. While the number down here is your index. So that index is going to go right here on your radical, and the a is being squared. So the way we would rewrite this would be 12 times the cube root of a squared. So essentially we eliminated the rational exponent to create a radical. Here's another one, same idea. Even though it's in parentheses, this 64a is still under the radical. So there's my radical. My exponent is a 4. Notice the whole thing is in parentheses, so I'm going to keep that in parentheses, and I'm going to put a 4 here. My index is a 5. So then this is what we would have here. Now we're going to take this one to exponential form. So b is the base, or the radicand. I'm going to create a fraction. Remember, this is your index, this is your exponent. The exponent is the numerator, the index becomes the denominator. So this would be b to the 3/5. Taking it to exponential form yet again. This one's a little bit trickier because we have the 27 and then d to the 5th power. So what I'm going to do is separate those two. So I have the cube root of 27 times the cube root of d to the 5th power. The reason I did that is because 27 is not attached to that exponent of 5. So the 27 would be to the 1/3. The d would be to the 3. I keep doing that. I'm so sorry. Would be to the 5/3. These cannot be combined because they're different bases and different numerators. or different exponents. All right, so here we're going to look at which of the following expressions is equivalent to 8x to the 4/3 power. So we would have 8 to the 4/3 times x to the 4/3. So what I'm doing here is I'm separating these two ideas, and what we need to realize is that they're both being raised to the exact same power. So if I were to write these, this would be 8 with an index of 3 and an exponent of 4, and this would be x with an index of 3 and an exponent of 4. So right away, I see I can eliminate b and d because the x is to the 4th power, not the 3rd power. Now I need to decide between a and c. When I look at c, I see 8 is not attached to this exponent of a 4. 8 should have an exponent of 4 somehow, or simplified further. So I'm going to eliminate c and say that it's a. If we went to plug this into a calculator or something like that, we should get back 16. So here's another one. Which of the following expressions is equivalent to 4 times the square root of b to the 5th power? I'm going to leave 4 hanging out front because it's not under the radical. We're not really going to do much with that. Having said that, f and h can be eliminated because I do not need to do anything with that 4. Then I have b. I have an index of 2. So my numerator or my denominator would be a 2 and the numerator would be a 5 because that's my exponent. So then I'm looking for 4b to the 5 over 2. So then it looks like j would be what we need. The parentheses would be the only difference. And because the 4 is not under that radical, we do not need the parentheses.